Hi, are you here to know what are the simple types of chemical reaction? So, welcome to this channel. Many chemical reactions can be classified as one of the 5 basic types. Having thorough understanding of these types of reactions will be useful for predicting the products of an unknown reaction. The 5 basic types of chemical reactions are combination, decomposition, single replacement, double replacement, and combustion. Analyzing the reactants and products of a given reaction will allow you to place it into one of these categories. Some reactions will fit into more than category. So now let's talk about the combination reaction. A combination reaction is also known as a synthesis reaction. It's a reaction in which two or more substances combine to form a single new substance. Combination reaction can also be called synthesis. The general form of combination reaction is A plus B form to AB. I will give you an easy understanding for the combination reaction. So combination reaction, also called the synthesis reaction, is just a fancy word for making. And that's exactly what will happen in combination reaction. A compound is made from simpler materials. For example, carbon plus the oxygen gas turns to a compound element called the carbon dioxide. Synthesis reaction is one where we start with the simpler materials and put them together to make a sample of something complex. So there is the carbon dioxide. So let's talk now about the decomposition reaction. A decomposition reaction is a reaction in which a compound breaks down into two or more simpler substances. The general form of a decomposition reaction is this. Most decomposition reactions require an input of energy in the form of heat, light, or electricity. We are now in the decomposition reaction. It is a kind of the opposite of the combination reaction. In a synthesis reaction, we put things together. In decomposition reaction, a compound is broken down into simpler compound, or all the way down to the elements that make it up. Okay, for example, H2O, or the water, comes from the composition of the hydrogen gas plus the oxygen gas. So what will happen in the decomposition reaction is the compound is broken down into simpler materials, and this is the hydrogen gas and the oxygen gas. However, in a decomposition reaction, you don't have to break things down all the way down to their basic elements. You can also break down just in a simpler compounds. I will give you another example. The calcium carbonate is a compound element that compose of the calcium oxide, which is the CaO, plus the carbon dioxide, CO2. As you can see, it's not like we're taking this and breaking it down into just calcium, carbon, and oxygen. No, that's not way of the process of decomposition reaction. We can also narrow it down or breaking it down into a simpler compound. So because there are simpler compound, it is also a decomposition reaction, which is the calcium oxide and the carbon dioxide. So let's talk about the single replacement reaction. It's a reaction in which one element replaces a similar element in a compound. The general form of a single replacement, also called single displacement reaction, is this. In this general reaction, element A is a metal and replaces element B, also a metal, in a compound. When the element that is doing the replacing is a non-metal, it must replace another non-metal in a compound. And the general equation becomes this. As you can see in my example, Fe iron starts out by itself, but in the process, iron kicks out the copper in the copper chloride. And it turns out to form that copper ends up by itself, and now iron takes the place of copper so that the iron and chlorine are now paired. So That will happen in a single replacement or single displacement reaction. Another one of the chemical reaction is the double replacement reaction. It is a reaction in which the positive and the negative ions of two ionic compounds exchange places to form two new compounds. The general form of a double replacement, also called double displacement reaction, is this. In this reaction, A and C are positively charged cations, while B and D are negatively charged anions. Double replacement reactions generally occur between the substances in aqueous solution. In order for a reaction to occur, one of the products is usually a solid precipitate, a gas, or a molecular compound such as water. We are now in a double replacement reaction or double displacement reaction. The positive and the negative ions in two compounds switch places. Nobody gets kicked out, and double replacement unlike the single replacement. So here is my example. All of these are compounds are ionic, which means that we can break them down into the positive and negative ions that they're made up of. So note that the positive ions or the cations are in green, and the negative ions or the anions are in pink. In my example, we have the silver nitrate and the sodium chloride. It's made up of the silver, nitrate, sodium, and chlorine. So as you can see, the positive and the negative just switch places. As you can see, the positive ions here, A, which is the silver, finds itself a new partner with negative ions anions, this element D, which is the chlorine. And another one, the sodium, the positive ions comes with a new partner, the element B, which is the nitrate. And now it turns to be the sodium nitrate and the silver chloride, which is the positive ions finds another negative ions and change its position and find its new pair. So that's happened in a double replacement or double displacement reaction. So now let's talk about the combustion reaction. It is a reaction in which a substance reacts with the oxygen gas, releasing energy in the form of light and heat. Combustion reactions must involve oxygen as one reactant. The combustion of hydrogen gas produces water vapor, a compound containing carbon and hydrogen and sometimes oxygen combines with the oxygen gas to produce carbon dioxide and water. So here is the example of a combustion reaction. So from the word itself, combustion, it is basically a fancy word for burn. And when something burns, what happens is that a compound containing carbon and hydrogen and sometimes oxygen combines with oxygen gas to produce carbon dioxide and water. So here is the example. CH4 is the chemical formula for methane, and that's a type of a natural gas, plus combines in with the oxygen gas, and it forms carbon dioxide and water. So another example is C3H8, which is the chemical formula of the propane, is another type of a natural gas, combines with the oxygen and forms the carbon dioxide and water. So these two reactions are essentially identical except for the number of the carbons and the hydrogen. So it turns out that a lot of things that we burn like the natural gas, the diesel, gasoline are really similar, and they only differ in the number of carbons and hydrogens that are in the molecular that or their molecules that make them up. So combustion reaction for a wide variety of the compounds look pretty similar. These are the types of chemical reaction and their generalized formation.